Hello everybody, I'm Alexy Khrabrov, the AI community architect at Neo4j, the graph database company out of Sweden. And here with us at PyBay, the 10th anniversary, we have Guido van Rossum, the creator of Python. We're very fortunate. Welcome, Guido.
Nice to meet you. Hello everyone.
And we're doing, as a company, we do graph rag, and we're in the midst of AI. We're just a graph database, but we do a lot of integrations of open source, and it was really great to see you talking about structured rag, and what a huge surprise, you're basically one of the cool kids doing AI now by virtue of doing rag. So how did you come to do that specific project at Microsoft?
The origin is that I had spent almost 4 years working on faster C Python with a great competent team, and I thought for myself it was time to move on and try something else. And by then, this was about October last year, it was clear that that had to be in the direction of AI, because the whole company was abuzz with AI, and every product has to have a co-pilot basically. The year before, everybody was running around like headless chickens, trying to do the same thing. So I had been playing a tiny bit with AI myself, discovering limitations of embeddings. Initially, my dream was to write sort of a code analyzer that I could ask questions about a large body of code that I had access to, but that I didn't understand, either not at all or not well enough. Eventually, I wrote 3 or 4 versions of that. The first few were terrible. At some point, I gave up, but sort of, I had that idea in mind, and I don't exactly know how the office of the CTO became my target. I think some people said, well, you could go there because they do advanced AI stuff and they would love to have you. So I approached the office of the CTO, and he said, well, for what you're interested in doing, there are really 2 projects reporting directly to Kevin, who is the CTO, that you might be interested in. And so after working with both projects, I sort of ended up with Stephen Luco's project. That's the story.
Yeah, this is great. And I met your colleagues, and they told me that your group is called AI Systems. So is it the idea to do systems, like distributed systems or software systems supporting AI? So that's an example. A database, indexing information, supporting AI.
I actually don't know the origin of that term, so I'll decline answering that.
Okay. I mean, I like systems, right? Like distributed systems, and a lot of AI is basically data, right? So now everything is AI, but I think everybody now understands that unless you have data sets, you cannot really do AI. And so you give examples, right? You have corpus of email or Monty Python text, and so you index and you put, from what I understood, right? You put information before, instead of just putting them as random vectors, you structure them. And so by virtue of having structure, they are better searchable and give better results. I want to follow up, and so I come from functional programming background, Haskell, Scala, and all this stuff. And so I've been, first of all, amazed how Python became the language of AI, and now we're all using Python. But then I've seen something interesting. Everybody's using Pydantic in AI specifically, and I think the origin, from what apocryphal stories I heard, is that LangChain folks were the first to use it, and I think Harris and Chase used this opportunity to learn Python by writing a client for OpenAI, and for some magic they used Pydantic, and so because LangChain became foundational in open source AI ecosystem, everybody picked Pydantic from this. And so what I've heard from Pydantic, there are 70,000 packages in Python using Pydantic. And so almost every open source AI package in Python is using Pydantic now. So when Pydantic cuts to a major version, so we have in Neo4j Python GraphRag package, which is using Pydantic, and we integrate with LangChain, which is using Pydantic. So we had to have a meeting when they're upgrading the version of Pydantic. We have to go in lockstep. So and Pydantic basically is a type system for Python, right? So this is basically written in Rust.
That's not how I would describe it at all, but sure.
So I'm curious. I'm just curious. So do you like again? As a guy coming from a type like very strongly typed languages, I was looking for familiar things, and so I found Pydantic, and then I was surprised that it's been picked up. So do you think it's? But there are other ways to do types in Python. So I just wonder, like, what do you think of this phenomenon, like rise of Pydantic? Since more and more people use it for all kinds of data, do we need more types? Do we need to annotate data? Like you have a structure. If this structure is formally, and you show TypeScript, right? So TypeScript would, like that thing would have a type. In TypeScript it will be a record. Do you think like something like Python is timely, should be a part of Python itself, if it's used so widely? Like what's your thought on types for Python at this point in Python?
Well, you know, Python has a static type system.
Correct.
Yeah, which I helped create.
Right.
Although Jukka Lehtosalo is the real creator, I just encourage him to make it compatible with Python instead of a preprocessor. No, in the Python world, nobody wants to use a preprocessor.
Right.
Anyway, we have that type system, and Pydantic came. And one sort of more or less accidental property of Python's type system, which is in contrast with TypeScript, is that Python types are runtime introspectable. I don't even remember the reason why we did that, except that we put a sort of a fledgling support for annotations in functions in Python 3.0 long before we grew this type system.
Yes.
But sort of by making the initially, the annotations were forced to be runtime introspectable because it was just an expression that was evaluated. And that the value of that expression was not used to influence the Python interpreter in any way, but it was curled away in a magic attribute of the function called dunder annotations. So sort of as the type system grew, we kept this property of type annotations must sort of leave behind, when you evaluate them the normal way, just as an expression, they must leave behind an object that represents all the aspects of the original, or at least all the relevant aspects of the original annotation. Like if you say this argument is a union of int and string, you would end up an object that says union, and it would have two attributes, or a list of attributes that is int and string. And for int and string, we just use the existing built-in classes. So Pydantic came along and made good use of that runtime introspection, and I thought, but I'm not an expert on the history of Pydantic, my understanding was that their original application was JSON validation for web servers or like REST interfaces, where you could validate that if someone sent you a request and it was formatted JSON, that didn't just parse using the JSON.load, because that's kind of a trivial requirement, but that it followed a certain schema, and that things in that schema were sort of, they added some things to the schema in a sneaky way. Well, there's an escape syntax in the type annotation syntax now, where they can add annotations like, not only must this be an integer, but it must be a positive integer less than 100 or something like that. Then they have like little notations for all that. And so that made it a very useful annotation language for validation of JSON, which initially I think was especially important just for any web UI.
Which is, a lot of uses JSON, and so speeding up JSON already gives you a lot of value.
And so they made a nice mapping between Python classes and JSON data, where you can sort of, you can say, here's a class and here's a blob of JSON. Now sort of try to make an instance of this class from that blob of JSON, and it either gives you a valid instance of the class or it gives you some error that says that JSON didn't actually have all the information I needed. How exactly they then became important in AI, I don't know, possibly because there's lots of JSON data around in that world. So if they used Rust just to make it faster. I don't know that their first version was in Rust.
Yeah, so that's a very good question.
Currently it certainly is.
Yeah, we have a community conference, in November, by the way, and Samuel Colvin, the founder, is coming to talk about it. So I'll definitely ask him this, because what I found, again, I came to Gen AI open source ecosystem fairly recently. I was running communities of people doing like distributed systems like Kafka and Spark and doing, and so, but because all AI is now Python, so I found that
but a lot,
a lot of it, right? So it's a huge success. I think Python basically is what facilitated AI on training side too, right? So PyTorch is basically the major training infrastructure.
The fact that PyTorch existed, I think, pushed the entire AI community in the direction of Python a little bit. The other, I think, part of that origin story probably has to do with NumPy and its usefulness for machine learning.
Yes.
Where instead of JSON data, you have data that is like millions of numbers in arrays.
Yes.
And Python already had a great solution for dealing with that efficiently in the form of NumPy.
Right. And all of AI is basically matrix multiplication. So if you have matrix multiplication, so I wonder what you think of this, because Python, I think, uniquely of all the languages, is interfacing with all kinds of native languages, right? So in like PyTorch is basically Python API into a blob of C++. I'm simplifying things. Yeah. And so Pydantic is basically, using Rust underneath to ingeniously use these annotations. And so Python is really flexible. It allows you to use things like like who knew these annotations will be used for like embedding a new kind of type system and using Rust or C++. So Python always like interoperate with this. So was it your initial intent that it will be effectively an API language, or did it just come because of the design?
The design, sort of the aspect of Python's design that you describe is called extension modules or extensions. That was in the language pretty much from day one. The reason was that I invented Python in the context of a novel operating system that had its own quirky I/O primitives. And so I wanted Python to work on Unix, but I also wanted Python to work on Amoeba, which was this quirky distributed operating system, which didn't natively support files or processes, or at least when it did, the syscalls were totally different. But basically, there was only one type of syscall. You make a request to a capability. So I knew that if I wanted to be able to use Python with Amoeba, which was my stated reason for developing it and letting my hobby time with Python bleed over in work time. I knew I didn't want to bake Amoeba primitives into the language, but I had to have some way, and so I knew that I had to have extension modules. The initial extension modules weren't even dynamically loaded. You had to sort of edit a little table somewhere deep in the source code and then rebuild Python from source. It wasn't, I think 5 years later or so, people started telling me, hey, did you know that there's dynamic linking? And I said, sure, send me a patch. The extensions, because they were always in the language and sort of quickly gained more power, especially through dynamic linking, they've always been sort of a very powerful mechanism to interface Python with everything else in the world, whether that is the Windows file system or the Linux file system or a set of Mac APIs or a big library that exists, like in the early days Xlib was an extension, I think, so you could communicate with an X Windows server.
Right.
And that was always my plan, and it was also a form of self-defense in the community, because there were lots of people who came to me saying, oh, Python is great, but I can't do this particular thing with it. And so having extension modules as an answer, where I said, well, that is just an API with a bunch of functions, so you can write an extension module and sort of invent a mapping between Python objects and types and the native objects or data structures of that library. Often they didn't even have objects. So then you map to tuples or things like that. Anyway, that was always my sort of defense against people who said, we need to change Python to support this or that. No, you can do this yourself. It's even better than A, I don't have to maintain it or think about how to implement it, and B, you can have your own release schedule, which is more than once per Python release.
So that was a Centrum Visconde in Informatica.
That was still at CWI, yes.
So I wonder, right? So this sounds like a great place, and recently we've seen DuckDB, another very efficient another thing which developers love. I wonder, what is it about the culture, LCWI? Is it pragmatic culture? Like, what made this place the birthplace of Python? Is there something special about it, or just serendipity?
I would say it was a classic research lab where researchers were given a lot of freedom to sort of develop interesting ideas into working code. There was also half of CWI is very mathematical and abstract. There's some very abstract computer science happening there too, but there's also a very pragmatic, practical side of the institute that sort of built software.
Interesting.
And sort of
so that the both
more
theoretical
and
practical
releases it as open source. When I started, Python was, I think, the first thing that CWI ever released as open source. And I'm still sort of, I feel so lucky that they let me publish Python as open source. The term open source hadn't even been invented, but the concepts were around because the X Windows system, which was something that we actually worked on, we had people working on that, and that was distributed under a very sort of lenient license that later became one of the standard open source licenses, the MIT license.
Right.
So I adopted that and crossed out the regions of Massachusetts Institute of Technology and wrote CWI in crayon, and that was all we did to the license. And that worked well.
Well, this is great. One question is, somebody from functional programming can help asking, and I wonder if it's true or not. So there was, like maybe a few years ago, there's a apocryphal story that, Python got lambda and map functions, and there was a paragraph attributed to you that you regret adding them to Python, and basically like the fork comprehension is easier for developers to read than the map. And I wonder if this is true, if this is something you wrote, or this is not somebody made it up.
Well, I don't know the particular paragraph, but I do remember expressing at various times some regrets over the particular form that this little bit of functional programming in Python took, because I wasn't myself familiar with functional programming, and I think I had a pretty wrong concept of what functional programming was. So initially we had lambda, which is an inline function that is in expression form instead of in statement form.
Yes.
And we had map, filter, and reduce.
Correct. Which is practically most of the functional programming for.
Well,
for most people.
For some people, that's functional programming.
That's right.
I almost immediately took a great dislike of reduce because I hadn't grown up with Lisp or APL, and as soon as code used reduce, even once, I would completely lose track of what that meant because I'm used to a certain procedural style of coding, and whether it's Algol or Fortran or Pascal or C or C++, that's all the same. JavaScript, TypeScript, C#. All those languages use the same kinds of paradigms for most of the coding.
Right.
Some of them, like Python, have little functional or functional-like corners, but most of the code that you write most of the time is procedural.
Right, loops.
Exactly,
Yeah.
lists and arrays and loops.
Arrays and
that's
loops.
what makes computers interesting, and that's what they're good at, honestly. Oh yeah, and if. That's about it.
That's right.
Functions for abstraction are just a luxury.
Fortran had all of this, and Fortran is
Yeah,
fast.
exactly.
Yeah.
So I didn't know exactly what I admitted into the language, and somehow the person who pushed the idea was very persuasive and came with a complete patch that applied flawlessly, and everything worked as promised, and it was understandable. So we put that in. So I started regretting a reduce. Then with Python 3, in Python 2, one of the warts with the functional stuff was that map and filter, at least, produce an entire array, which loses a lot of the elegance of using map and filter if you sort of stack them. Maybe you write multiple filters, and you begin or end with a map, or there's a map.
So they're
in the
eager,
middle.
they're not lazy, they're not
Exactly, they were eager, and so for each level of intermediate result, you'd have another array, and as long as those arrays are like 100 or 1,000 long, nobody cares, honestly. But if you have some real data, and it's a million lines, a million data objects, then you really don't want to have several arrays of length a million
each.
all sitting around until you're done with your computation.
Right.
And so that's why we changed it in Python 3, just like we changed keys and values of a dictionary to also be.
Yeah, so this is, I really appreciate it because, I was always curious, and basically what you said now, I think that kind of confirms this. The paragraph was about like, this is not Pythonic style. So like the full comprehension is just more it does the same thing, but it's more understandable visually for the developers.
Because also it can be faster, and especially since I think 3.12 or so, where Carl Meyer did an enormous amount of work on how list comprehensions are implemented, or comprehensions in general. And so to reduce the overhead. But the key difference is that when you have a lambda is implemented, even though it has different syntax, it's implemented at exactly the same as a def. So it's a function, it has a stack frame, it has arguments, it returns a value. The syntax you use to do all that is different, but you can make lambda work pretty hard. The problem with that is, if you have a simple lambda, like is lambda x colon is x greater than 0, because you only want the positive entries from a list. And if you call that a million times because you have a list of a million floating point numbers that you want to filter, that function call overhead costs you way more than all the loop overhead together. And so this is where list comprehensions, because they don't have a function call overhead, they don't necessarily have their own stack, can be faster.
Right, makes sense. And what I found personally,
and we have a lazy version too, even though they're called generator expressions, they use the same mechanisms and the same syntax.
I was looking because at the period when I was switched to Python, I was looking for functional kind of libraries, like nobody's really using this. In Pythonic code, people are using lambdas and map and reduce.
Correct.
They're doing like, and I found like actually
because they've been obsoleted by comprehensions largely.
Right. Yeah. So that's interesting. So that's good. I was able to clarify that for posterity. So now that you're in, like basically, Python is powering a revolution. You're in the midst of it now. You're at Microsoft at the AI Systems Group.
I still feel like I'm standing on the sidelines, and that's where I like to be at this point in my life. Soon I turn 70.
It's now a young age, right? 70 is the new 30. So
no, I don't feel it that way. I've had a hip replacement. I need a cataract surgery. I got a lame knee, or at least a wobbly knee. I need more sleep, and my sleep is worse in quality. So I don't feel as productive. My memory is often very leaky. I won't remember the names of any people I met here. I will remember the faces though. That's
maybe
interesting.
we put them in the graph rack.
Yeah.
Kind of.
Well, anyway, I'm looking forward to retirement in the next few years.
But still,
sure.
right? Like, I think it's amazing. You basically, created the language which is now everybody in San Francisco, everybody in AI, right? the kids are coming to Python. They don't know what graphs are. So, we're in a graph database. They think graphs are charts. So that was my...
Oh,
right?
Yeah, it's such
they think graphs are charts. They think graphs are charts.
Clash.
But what's interesting, right? So what's amazing to me, that Python is so ubiquitous. A lot of people who never study computer science, they pick it up and they are able to do it. And now, because of vibe coding, right, whatever it is, it's now now Claude Code, Cursor, Copilot, they're producing like gobs and gobs of Python.
Honestly, if you ask them to produce TypeScript, they can do that just as well.
And they do TypeScript. But what do you think?
Or almost any other language, I'm convinced. Never tried it, but I'm convinced that they know all the languages well enough.
So the final question is basically, now that basically, so you're basically okay with vibe coding. It's good for its use, like converting things to async.
I don't call that vibe coding because I know exactly what the outcome is.
Mm-hmm.
And I always go over the diff. And for that particular diff, I knew what to expect. Basically, there would be a bunch of defs that had async in front of them and a bunch of calls that had await in front of them, and those were the only expected changes. Mm-hmm. And so I just sort of paged through the diffs, making sure that those were in fact the only changes it had applied.
Yes.
And I paged through the bottom of it. This was a lot of pages. Mm-hmm, mm-hmm. And then I said, okay, I can commit this.
Yes.
And in other cases, like that inspect disaster, I also found out just by looking at the generated code or the generated changes.
So you reviewed all the changes.
Basically, every once in a while I'm lazy and I think, well, it passes the test, so what? And several times I've regretted that.
So, but this is a great story, right? So given with the state we're in, so we have this whole AI ecosystem, Python basically everywhere, right? And even vibe coding or agentic coding emerging. So what do you, we have a lot of students here, right? What would your advice to young people here? What should they study? So they study Python. I think everybody should study Python at this point. Even if you're non-technical coming to AI, you probably should study Python.
There are plenty of people who just don't have a head for coding and who you just make miserable if you force them to study Python. So I would take that with a grain of salt. Mm-hmm. In general, I'm a coder. I get endorphins from coding. Mm-hmm. I am not a teacher. I am not a life coach. I have no idea what to tell students. You gotta have a more specific question. Someone asked me a similar question, like, what advice do you have for new engineers?
Right.
And I gave the exact same answer. And then he started asking, and he had specific questions. Actually, he ended up asking about how I used AI and what I thought of it. Uh-huh. And there I had an answer.
Okay.
From what you've just heard.
From what you described, right? It sounds to me then folks who do vibe coding should think of this as a a good use case instead of right like making, because a new problem of the Cloud Code would make stuff up, but like massive refactoring, massive change, which is kind of well understood, is something that is good at, right? So maybe
and it's not vibe coding.
It's not vibe coding.
Not all code generated or updated by an LLM is vibe coding.
Right.
It's vibe coding when you don't care about what the code looks like, when you don't review that diff, you only care if it works.
Yes.
And if underneath it has written a million lines of spaghetti code, you couldn't care less, because the next time you want to change something in that pile of spaghetti code, you're also going to ask the LLM to make the updates. And if in order to add your simple feature, it has to write another million lines of code, or, well, who cares?
Yep.
And that is vibe code.
That's vibe code.
That's, I thought, where sort of Eric Meyer was standing on vibe code.
I don't think that's his idea. I mean,
not anymore. Okay.
Yeah, I think he delegates that right to LLM runtime. But again, I need to know more. But I think that the code that people write just becomes very high level. So I think the real question now, if the prompts we're writing should be natural language or should be new AI first languages, which will be like English but more Prolog-like, which more structured, and the prompts may be composable. I don't know.
Now you have to teach people how to write that Prolog, and the first thing they will go to is they will ask an LLM to write a stupid Prolog for them. So I don't think that that's a solution at all. I mean, what I started with actually was a large collection of interfaces and implementation classes that had been carefully coded by a crack team, people who really knew what they were doing. They knew the language, they knew the problem, they were sort of developing answers for the problem as they were going. But they ended up with like a list of public interfaces. These are interfaces like, this is the minimum spec for a message.
Yes.
This is the minimum spec for a conversation.
Yes.
These are the methods on conversations that you can call. These are the types that they return. And by and large, all I had to do was translate that to Python syntax, which was also a task that a model did pretty well. Both, especially the specs, but also the actual implementation code. I definitely had to sort of also review that carefully and catch the occasional weird thing. But Python and TypeScript are close enough together that it wasn't such a big deal. It became harder when I started to add the SQLite backend, which meant I had to sort of invent from scratch an API for a storage provider. And we did a good whiteboarding session with my team over 3 days, I don't know, I think in August or so, where we came up with a rough sketch of the schema and the APIs for that storage provider abstraction. And then it was straightforward to fill that in. And still, the LLM, I guess I didn't write carefully enough what I wanted, but I don't think that having to write it in the form of triples would have helped much. But by sort of reviewing what the LLM did and keeping the parts that were okay, every once in a while I made a small manual correction. Usually I thought, well, if the LLM wrote the code, it can pretty well correct it as well. So if I saw a typo somewhere, I would just tell it there's a typo on line such and such of this file, fix it, and it would do it.
Yep. I wonder, since you mentioned translation TypeScript to Python, it just occurred to me that the creator of TypeScript is also at Microsoft. Do you talk to him? Do you guys talk? Yes.
Yes, well, Steve is also involved, my boss. I don't know if you've met him.
Luca, yeah, great guy.
He and Anders sort of are together the origins of TypeScript. So, but I do actually talk to Anders regularly. He was even my onboarding mentor when I started 5 years ago.
Interesting. So this is great.
He's a great guy. He's totally a great guy.
I just talked to Steve, because it immediately occurred to me that what you do is basically very suitable for graphs because all the names you extract in structured information can be nodes and can be interlinked. So he's going to look at using Neo4j as a backend, as a storage backend. So I will definitely be happy to work with him to see, because if we can put all of this into Neo4j, we have all the same records, but now we can link them. For instance, all the names of a person, we can create a node, and so maybe we can take it further and have more fun with it. So that was my inspiration.
You could try just contributing Neo4j
Neo4j
storage backend.
Correct. Yeah. I mean, that sounds like a great thing. So thank you very much. I think now I understood your talk even better after you explained. Hopefully, this Fika AI episode will be a nice complementary, material to the main talk. And so we really appreciate, this opportunity, Guido, and I'm really happy, to meet you. And thank you so much, and wish you.
You're welcome.
Many happy years of contributing to Python and AI.